Assalamualaikum warahmatullahi wabarakatuh. Today, our group will present about business mathematics assignment. So first of all, I am a first presenter. My name is Muhammad NORHAKIM bin NORAZMAN. My metric number is 1202329. So I will explain about compound interest. First of all, what is an interest? Interest is the amount that has been paid by the borrower to the lender because of using the capital. There are two types of interest, simple interest and compound interest. Next, we go to the compound interest. Compound interest is based on the principal amount, which changes from time to time. At the end of each interest period, the interest earned for that period is added to the principal, the invested amount, so that it too earn interest over the next interest period. Compound amount is also called the accumulated amount. So the formula for compound interest is S equal to P 1 plus R the power of n. The difference between the compound amount and the original principal is I equal S minus P. So we go to the example. Suppose that $500 amounted to $588.38 in a saving account after 3 years. If interest was compounded semi-annually, find the nominal rate of interest compounded semi-annually that was earned by the money. So the solution is we using the formula S is equal to P 1 plus R to the power of n. So the R or nominal rate is 0.0275. Thus the semi-annually nominal rate is 2.75%. So the nominal rate is 5.5% compounded semi-annually. Next, we look at another example. 20,000 ringgit is invented in an investment fund that pays 6% compounded annually for 10 years. The question is find the compound amount and find the interest earned. So the compound amount is 35,816 ringgit 95 cents. Meanwhile, the interest earned is 15,816 ringgit 95 cents. So that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AMJAD bin SALAHUD-DIN. My metric number is 1202333. Today I will present to you about present values. So let's move to the first part, which is introduction. In the introduction, I will explain to you about the basic formula in present values. The principal P that must be invested at the periodic rate of R for n interest periods so that the compound amount is S is given by P equal to S in bracket is 1 plus R to the power of negative n and is called the present value of S. So after we learn the basic formula in present values, we go for the example 1. The question is find the present value of $1,000 due after 3 years if the interest rate is 9% compounded monthly. For the solution, we use equation in bracket 1 with S equal to 1000, R equal to 0.09 divide by 12 and we get 0.0075. And for n equal to 3 in bracket 12, which means 3 times 12 and we get 36. After all the data that we get the data into the formula, which is P equal to 1000 in bracket 1.0075 close bracket to the power of negative 36. We get 764.15. So this means that $764.15 must be invented and 9% compounded monthly to have $1,000 in 3 years. So let's move to the example 2, which is single payment trust fund. For the question, a trust fund for a child's education is being set up by a single payment so that at the end of 15 years, there will be $50,000. If the fund earns interest at the rate of 7% compounded semi-annually, how much money should be paid into the fund? For the solution, we want the present value of $50,000 due in 15 years. So what we do is from the equations in bracket 1, we got S equal to 50,000, which is the present value. R equal to 0.07, which is the rate, divide by 2, and we get 0.035. And for the N, which is the power, N equal to 15 in bracket 2, which is 15 times 2, and we get 30. So after all the data that we get from the question, and we gather it into the formula, so we get P equal to 50,000 in bracket 1.035 close bracket to the power of negative 30, and we get the answer is 17,813.92. So this amount should be paid into the fund. So let's move to the example 3, which is equation of value. The given problem is a debt of $3,000 due 6 years from now is instead to be paid off by 3 payments, which is 500,000 for now, $1,500 in 3 years, and a final payment at the end of 5 years. What would this payment be if an interest rate of 6% compounded annually is assumed? For the solution, let X be the final payment due in 5 years. For computational convenience, we will set up an equation of value to represent the situation at the end of that time. For in that way, the coefficient of X will be 1. Notice that a year 5, we compute the future values of $500 and $1,500 and the present of value $3,000. The equation of value is, we get the data from the question, and for the solution, we mix the data into the formula. So we get 500 in bracket 1.06 close bracket to the power of 5 plus 1,500 in bracket 1.06 close bracket to the power of 2 plus x, which means the x that we should find. So this formula equal to 3,000 in bracket 1.06 to the power of negative 1. So we bring the x into the front of the formula because we want to find the x, and we get 3,000 in bracket 1.06 close bracket to the power of negative 1 minus 500 in bracket 1.62 close bracket to the power of 5 minus 1,500 in bracket 1.06 close bracket to the power of 2. So the answer for this equation is 475.68. So the final payment should be this answer, which is $475.68. Now we go to the example 4, which is comparing investments. For the question, suppose that you had the opportunity of investing $5,000 in a business such that the value of the investment after 5 years should be $6,300. On the other hand, you could instead put the $5,300 in a savings account that pays 6% compounded semi-annually. Which investment is better between these two? So we should compare whether 5,000 is better or 600 and 6,300. For the solution, let us consider the value of each investment at the end of 5 years. At that time, the business investment would have a of a value $6,300, while the savings account would have a value of $5,000 in bracket 1.03 close bracket to the power of 10. So we get for the 5,000 equal to $6,719.58. So clearly, the better is putting the money in the saving account. Now we at the end of the discussion of present value, which is for the example 5. The topic is net present value. So the given question is, suppose that you can invest $20,000 in a business that guarantees you cash flows at the end of years 2, 3, and 5, as indicated in the table to the left. Assume an interest rate of 7% compounded annually and find the net present value of the cash flows. So for the solution, we should subtracting the initial investment from the sum of the present values of the cash flows given. So the net present value given is 10,000 in bracket 1.07 close bracket to the power of negative 2 plus 8,000 in bracket 1.07 close bracket to the power of negative 3 plus 6,000 in bracket is 1.07 close bracket to the power of negative 5 minus 20,000. So what we get is negative 457 negative 457.31. So we should explain the answer, which is since net present value is less than 0, the business venture is not profitable. If one considers the time value of money, it would be better to invest the $20,000 in a bank paying 7% rate. Since the venture is equivalent to investing only $2,000 minus $457.31 that we get is $19,542.69. So that's all from me, which is we have 5 example under the present value. So thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am AZLAN bin Muhammad ROSAFIE, number metric 1202283. So today I want to present about future value. First of all, future value is a value of a current asset at a future date based on assumption rate of growth or interest rate. The future value is important to investor and financial planner as they use to estimate how much an investment made today will be worth in the future. So future value also enable investor to make sound investment decision based on their anticipated needs. However, external economic factors such as inflation can be adversely affect the future value of the asset by eroding its value. So to understand further about the future value, the future value calculation allow the investor to predict the amount in the future with the variety interest and year that they held the cash. The amount of growth generated by holding a given amount in cash will likely be different than if the same amount will invested in stock. Therefore, the future value equation is used to compare the multiply option. Determine the future value of an asset can be complicated depending on the type of asset. So the future value calculation is based on assumption of the stable growth rate. If its money is in saving account with a guarantee interest rate, then the future value is easy to determine accurately. So there are two types of future value. which is one is future value using simple annual interest, and second is future value using compounding annual interest. So first, the future value using simple annual interest is the future value uh, equal to investment amount multiplied by 1 plus interest rate multiplied by number of year or the period in the kurangan. For example, assume the 10,000 investment is held for 4 years in saving account with the 7% simple interest paid annually. So just take the amount, put in the formula. So the last or the cumulative or the end of the investment, the amount, the future value will be the 12,800. And next is the compound future value using compounded annual interest. Compounded annual interest is just like same like the annual simple interest, but the each value of investment amount will be different by year or by year because they use the cumulative balance to make the investment. So the formula is the future value equal to investment amount in kurungan 1 plus interest rate to the power of period or the number of year. So using the same example from previous, the 10,000 invest for in 4 years in saving account with the 7% compounding interest rate. So take the numbers, put the in the formula, so we will get the future value at the end is 13,107. And last but not least, to make it simply, so the future value using annual interest rate is future value equal to investment amount multiply by 1 plus interest rate multiply by period, and the future value using compounded annual interest is future value equal to investment amount and multiply by 1 plus interest rate to the power of the period. Okay, thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AMIR HUZAIFAH HASMIZAL. Matric number 1202352. I'm from KMA 1. I'm from group 18. And here I want to present about annuity. An annuity is a series of payments made or received over a predetermined period of time. There are two types of annuity. First, ordinary annuity. Second, annuity due. Ordinary annuity is a payment at the end of the period. It usually paid monthly, quarterly, annually, and for example, home mortgage. Annuity due is uh, they paid immediately. Uh, Usually it paid at the beginning of period. For example, rent. First, we're gonna look into the present value of an annuity. It is the sum of the present values of all N payments, and it represents the amount that must be invested now to purchase all N of them. The formula for the present value of an annuity is A equals to big R multiplies with 1 minus 1 plus small r to the power of negative n over small r. The big R first is the payment per period. The N is the payment period, which is the time, month, year, or week. R is interest rate. For example, for question 1, find the present value of an annuity of 300 ringgit per month for 4 years at an interest rate of 6% compounded monthly. The answer, first we substitute R equals to 300, R 6% of interest rate 0.06, we divide by 12 because it compounded monthly, equals to 0.005, and N equals to 4 years times with 12 months equals to 48 months. So the answer A equals to 300 times 1 minus 1 plus 0.005 to the power of negative 48 over 0.005 and get 11,339 ringgit 49 cents. Next, example question 2. If 20,000 ringgit is used to purchase annuity consisting of equal payments at the end of each year for the next 5 years, and the interest rate is 6% compound annually, find the amount of each payment. The answer, A equals to 20,000, N equals to 5, which is 5 years, R equals to 0.06, and we want to find R. R is the payment per period. So, from the formula, we left R to the left side, which is R equals to A over 1 minus 1 plus R to the power of negative N over R. So it becomes R equal to 20,000 over 1 minus 1 plus 0.06 to the power of negative 5 over 0.06, and we get the answer. We will get 4,747 ringgit 93 cents. Next example, question 3. The premium of an insurance policy are 75 ringgit per quarter, payable at the beginning of each quarter. If the policyholder wish to pay 1 year's premium in advance, how much should be paid, provided that the interest rate is 4% compounded quarterly? The answer, the present value of an annuity is 75 ringgit per period for 4 period at interest rate of 1% per period. It says each payment is due at the beginning period, so it is an annuity due. The given annuity is an initial payment of 75 ringgit followed by an ordinary annuity of 75 ringgit for 3 period. So to calculate the annuity due, A equals to R open bracket 1 plus 1 minus 1 plus R to the power of negative n over R close bracket. So according to the information, we include into the formula A equals to 75 open bracket 1 plus 1 minus 1 plus 0.01 to the power of negative 3 over 0.01 close bracket. So we will get the answer 295 ringgit and 57 cent. Next, we're gonna look into the future value of an annuity. It is the sum of the future values of all n payments. The formula is S equal to R times 1 plus R to the power of n minus 1 over R. For example, question 4. Find the future value of an annuity consisting of payments of 60 ringgit at the end of every 3 months for 5 years at the rate of 6% compounded quarterly. So R is 60, N is 5 years times 3 months, and we will get 15 months. R, which is interest rate, is 0.06 divided by 4 equals to 0.015. So from the formula we got S equals to 60 times 1 plus 0.015 to the power of 15 minus 1 over 0.015. So the answer is 1000 ringgit 93 cents. For question 5 example, at the beginning of each quarter, 55 ringgit is deposited into savings account that pays 6% compounded annually. Find the balance in the account at the end of 5 years. The answer, the future value of an annuity is 55 ringgit per period for 1 period at interest rate of 6% per period. Deposit payment is made at the beginning of period, so it is an annuity due. The given annuity can be thought of as an ordinary annuity of 55 ringgit for 4 periods minus the final payment of 55 ringgit. So to calculate question 5, we use the formula S equals to R 1 plus R power of n minus 1 over R minus 1. So according to the formula, we put the information into the formula, which is S equals to 55 open bracket 1 plus 0.06 to the power of 4 minus 1 over 0.06 minus 1 close bracket, and we will get the answer 1102 ringgit 27 cents. For question 6 example, a machine that costs 7,000 ringgit is to be replaced at the end of 8 years, at which time it will have salvage value of 700. In order to provide money at that time for a new machine that costs at the same amount, a sinking fund is set up. The amount is in the fund at the end of 8 years is to be difference between the replacement cost and salvage value. If equal payments are placed in the fund at the end of each quarter and the fund earns 8% compounded quarterly, what should each payment be? So the answer is first, a sinking fund is a fund into which periodic payments are made in order to satisfy a future obligation. The amount needed after 8 years equals to 7,000 minus 700 equals 9,300. The payments into sinking fund form an annuity, which is n equals to uh, 4 times 8 equals to 32. The rate 0.08 divide by 4 and we get 0.02, and for the S, which is future value, 6,300. So from the formula, 6,300 equals to R times 1 plus 0.02 to the power of 32 minus 1 over 0.02. We want to find R, which is payment per period. So we make R to we put R to the left side, and it become R equals to S over 1 plus R to the power of n minus 1 over R. So we put the information into the formula. R equals to 9,300 over 1 plus 0.02 to the power of 32 minus 1 over 0.02, and we will get the answer 142 ringgit 45 cent.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad FARHAN bin ABDUL RAZAK and my matrix number is 1202321. So I am going to explain about amortization. So what is amortization? Amortization is an accounting technique used to periodically lower the book value of a loan or an intangible asset over a set period of time. Concerning a loan, amortization focuses on spreading out loan payments over time. And when applied to asset, amortization is similar to depreciation. In understanding amortization, amortization refers to two situations. First, amortization used in the process of paying off debt through principal and interest payments over time. An amortization schedule is used to reduce the current balance on a loan. Second, amortization refers to the spreading out of capital expenses related to intangible assets over a specific duration. So the formula for the amortization is, one of them is called the periodic payment, which is the capital R equals to capital A multiplied by R divided by 1 minus 1 plus R to the power of negative n. So capital R is equals to the monthly payment and the capital A is equals to the principal, and the small r is the monthly rate and the n is the total month payment. Example given for this formula is, suppose that a person borrowed $200,000 amortized by over 30 years at 5% of rate annually. So if we use the formula we learned just now, R is equal to $200,000 multiplied by 0.05 divided by 12 divide by 1 minus 1 plus 0.05 divided by 12 to the power of negative 12 multiplied by 30, and we got negative 360. So for the answer is R, which is the monthly payments, is $1,073.64. So from the total monthly payment that we get just now, we also can get the total payments and also the total interest paid by the formula NR minus A. So for the total payments, we just use the NR, which is $1,073.64 multiplied by 360 equals to $386,510.40. And for the total interest paid is the total payment minus the principal, which is $386,510.40 minus $200,000. So we get $186,510.40. That's all from me. Thank you.
And lastly, the topic is effective rate. Before that, my name is AMZAR HAKIM bin ROSLAN 1202284. What is effective rate? The effective rate is the real return on a savings account or any interest-paying investment when the effects of compounding over time are taken into account. It also reveals the real percentage rate on or in interest on a loan, a credit card, or any other debt. The more frequent the compounding period, the greater the return. Next is the formula for the effective rate. Effective rate SR equal 1 plus I per N square N minus 1. I as nominal interest rate, while N is as number of periods. For the example, for interest rate, question 1. A deposit scheme offers an interest rate of 6% per annum. Compounded quarterly, what is the effective rate of interest? The answer, actual rate of interest is 6% or 0.06 for 0.015 per quarter. Number of conversion periods N is 4 since we are calculating for 1 year and compounding happens every quarter. So the effective rate is 1 plus 0.06 per 4 square 4 minus 1. So the answer is 0.0613 or 6.13%. Next question. Investment A pay 10% interest compounded monthly. Investment B pay 10.1% compounded semi-annually. Which is the better offer? The answer. For investment A, this will be 10.47%. By use the formula 1 plus 0.01 per 12 square 12 minus 1, so get the answer. And for investment B, it will be 10.36% by use the formula 1 plus 0.101 per 2 square 2 minus 1. So investment B has a higher stated nominal interest rate, but the effective annual interest rate is lower than the effective rate for investment A. This is because investment B compounds few times over the course of the year. Last example. You have just purchased a home by borrowing $385,000 for 30 years at a fixed APR of 3.85%. The loan payments are monthly and interest is compounded monthly. What is the effective annual rate on the loan? In other words, what is the interest rate once you take into account compounding? The answer, R is 3.85% and is 12, loan is $385,000. 1 plus 0.0385 per 12 square 12 minus 1, so get the answer is 3.92%.